Okay, first thing we're going to do, guys, is go through the shortcut way of factoring. And I want to talk to you about how I used to teach factoring. Some of you have this down pat already. The quiz grades, I'm still waiting on a couple people to finish, and several people who are absent to take the quiz. We'll go over that next time. But I want to show you how I taught factoring before this year. The only way I ever knew how to teach factoring was guessing and checking. Okay, and it's easy. This method is easy on problems like this. So you're probably going to like guessing and checking on problems like this. Now, what's unique about these two problems? Or what's easy about these two problems? What is it? They have a 1 in front of x squared. The value of a in both of these problems is a 1, and that makes your factoring so much easier. This is how we would do it. We would just write our two blank parentheses down, and you have to know that whatever goes here and here in the first two positions has to give you x squared back. That's when you multiply the first two terms, always has to equal what's in this position. Well, that's easy. What does it have to be? X times x. What goes in the last two positions has to multiply together to give 12. Now, it could be 1 and 12, it could be 2 and 6, or it could be 3 and 4. And I know you guys can already see the answer's got to be 2 and 6, but let me just show you what we would have done in the past when I first taught this. We would just start guessing, and we might have started with 3 and 4. The middle term has to be an 8x, and the middle term comes from your inside product and your outside product. Will 3x and 4x ever make an 8x? That's how I would know that 3 and 4 is not the right guess. And you guys already knew 3 and 4 was not going to be the right guess. What was? 6 and 2. And I can tell from the signs they both have to be positive. And that gives me x squared plus 2x plus 6x, and it gives me a plus 12 on the last term. And these two in the middle definitely add up to 8x. So we didn't have to go through that process of GCF and all that good stuff. Now, could you still do it? Absolutely. But when your x squared value has a 1 in front of it, we can always do this little shortcut. And I do want you to be familiar with the shortcut. I'm having some kids having trouble finishing the factoring in time. And we'll probably take a test on this before you leave for Thanksgiving holidays. Okay, look at this problem. X squared minus 9x plus 20. Could I do the shortcut on this? Yes. The value of a is a 1. So I just have to think of the factors of 20 that could add up to a negative 9. It has to be 4 and 5. Now, they have to add up to a negative 9. So what would both signs have to be? Yeah, it'd be minus 4 and minus 5. That would give me a positive 20 on the end. And I'd get negative 4x and negative 5x from the inside and outside. And that adds up to negative 9x. Okay, because guessing and checking is not fun when it's not a 1. And I wanted you to understand that process on the easy ones before we got to the harder ones. Let me show you where guessing and checking is not as fun. And that's why I like what I learned at my workshop this summer. I like this process. Because look what happens when you get to problems like this. 15y squared plus 17y minus 18. Now here's where guessing and checking is not going to be fun. Because guess what? For 15y squared, I could either have 15y and 1y, or I could have 3y and 5y. For 18, I could have 18 and 1, or 1 could go here and 18 could go here. Or I could have 6 here and 3 here, or I could have 3 here and 6 here. And guess what? None of those might not be the winner. It might be the 3 and 5 for 15. Do you see how much guessing and checking could be involved here? So that's why I really, really liked the process that I found out about that I had never seen before. And so I definitely want you to understand how to do that process. Okay, but if you see one that's got an a value of 1, then I would encourage you to do the shortcut. You could do it the long way if you wanted to. Here's another thing I want to go back and review real quick. The strange cases or weird cases, because there was 2 of these on the quiz, and some kids blanked out when they saw it. And when we did this lesson, you guys thought it was super easy, and it is. The hard part is recognizing it again when it shows up on a quiz or a test. Weird cases involve binomials. It's not normal to factor a binomial into more binomials. That's weird. In these cases, either something is missing. Either the middle term is going to be missing, the b value, or the last term, the c value, is going to be missing. Okay, and that makes the problem, really, it makes it easier if you recognize it when you see it. Here is one of those cases. What's missing here? The b, the middle term, the x's, the bx's. It's like we have x squared minus 0x or plus 0x minus 16. There's nothing in the middle. The b is missing. When the b is missing, 9 times out of 10, that's going to be the difference of 2 squares, which makes your life so much easier. You don't have to go through that process. You could if you wanted to, of multiplying a times c and then finding the GCF and all that good stuff. What's the shortcut way to factor this? You just take the square root of each term. Square root of x squared is x times x. What's the square root of 16? 4 and 4. One has to be a plus and one has to be a minus. That forces the middle term to cancel out. And if you're ever not sure, multiply it back. You would get x squared minus 4x plus 4x, and then you'd get a minus 16 on the end. What happens to those two terms in the middle? They cancel out. But I saw all kinds of weird things on the quiz. I saw people doing x plus 8 and x minus 2 or strange stuff like that. That's not ever going to work. Why not? It would give me a negative 16, but would I get a 0 in the middle? No. Okay, so you've got to recognize those weird cases when you see them. What about 9x squared minus 49? I don't have to go through that whole process, nor would I want to. I should just recognize, hey, this is a weird case. It's a weird case because there's only 2 terms. And I need to recognize what's missing here. Just like on the last one, the middle is missing. And you should start to recognize those perfect squares like 9 and 16 and 25 and 36 and 49 and all those perfect squares. You should hopefully recognize those. These are definitely 2 perfect squares being subtracted. This is the difference of 2 perfect squares. How would I factor that? Just square root it. And what is it? 3x plus 7, 3x minus 7. Or you could put the minus first and the plus second. Another thing you've got to make sure, though, is that you have different signs. I had some kids realize it was difference of 2 squares, but they made both of them negative or both of them positive. Why do I have to have different signs? So the middle will cancel each other out. This would give you back 9x squared minus 21x plus 21x. That's what makes those cancel each other out. And then you would still get that negative 49 on the end. You also need different signs so you can have a negative number at the end. If you had same signs, this wouldn't have been a negative 49. It would have been a positive 49. Okay, here's the second kind of weird case that you might encounter, and you will today on your lesson as well. Again, it's still a binomial. Now, this is not the difference of 2 squares. First of all, 3 and 6, neither one of them are perfect squares. And the b is not what's missing here. What's missing here? When the c is missing, I hate to use the word always, but that's 9 times out of 10 going to be a GCF problem, where all you can do is take out a GCF. So this won't factor into 2 binomials like we're used to doing. What's the only thing I can do to this? Take out a 3x. And what am I left with? X minus, not x minus 2x, just x minus 2. That's all you can do to that thing. It's not 2 binomials, it's a monomial times a binomial. So when the c is missing, all you can do is GCF it. It's not going to become 2 binomial parentheses. It's going to be a cluster you take out and then what's left after you take it out. And that does happen sometimes. It's a weird case. How do I know it's a weird case? Something's missing. There's not 3 terms here. The C is missing. That's probably going to be a GCF problem. Okay. So we know about the shortcut. We know about the 2 weird cases. Today what we're doing is combined types of factoring. Everything that you have been working on so far has been rigged to where it matched whatever lesson we were doing. Well, from here on out, they're just going to throw a whole bunch of different types of factoring at you, and you've just got to factor accordingly. And there is something additional that they're adding, and it's not on every single problem, but from here on out, the first thing you should always do when you're factoring anything is look for a GCF and take it out if there is one. First thing you should always do from here on out. Factor out the GCF if there is one. There's not always going to be a GCF, but if there is one, you got to get it out of there. It makes the rest of it so much easier. It makes the numbers smaller sometimes. Sometimes you're going to have an extra variable in there that you got to get out or you can't factor. All right. THERE, that's the right there. That is the location there. Right? All right, a real quick English lesson because this drives me nuts. This is what ownership, right? This is when you belongs to something, and this is they are. Okay. Now, after you take out the GCF, if there is one, then you factor what's left, if you can. Sometimes after you take the GCF out, you're done. But if you can keep on factoring, you want to keep on factoring. Now, here's a clue that you need to keep on going. Your exponent usually tells you how many factors you should have when you're done. So if you've got an exponent of 2, you should have 2 factors when you're done. If you've got an exponent of 3, you should have 3 factors when you're done, and so on. So if you've got something that still has an exponent in it, you probably want to keep on factoring that part. Example. Let's do some examples. Great idea. Okay, here we go. 3x to the 3rd power plus 15x squared plus 12x. First of all, what's my highest exponent? A 3. That means I should have 3 factors when I'm done. Now, it might not necessarily be 3 sets of parentheses, but it'll be 3 groups that all have an x in it somehow, some way. Have we ever factored anything with the x to the 3rd yet? No, this is different. Your first step from here on out, especially if there's a weird exponent, is greatest common factor. I can't factor this thing into 2 binomials. It's not possible. But there is definitely a GCF in here. What is it? A 3 and an x. Now here's why we want to take out the 3. The 3 reduces all the coefficients, which makes your life easier, trust me. And we have to get the x out of there because we can't factor it like it is. We're used to factoring x squareds into x times x. So I need to take out a 3x. Now what am I left with? X squared plus 5x plus 4. Okay, I have broken this down into 2 sets of factors. One of them I'm not done with. Which part am I not done with? This business. This part of it is still factorable, and a clue that it is I've still got an exponent of 2. I want all my x's to just be plain old x's when I'm done. But one of my factors here was just this GCF, this 3x. That's definitely part of my answer, so don't lose that 3x. I'm going to write it down here so I don't forget it. It's got to be part of my final answer. Now, let's look at what's left. You can kind of ignore the 3x now, but make sure it's in your final answer. Pretend like we just had this. And we factor that like we've always done. You can do it the long way, or this is one that you can do the shortcut way. How do I know I can do this part the shortcut way? Because the value of a is now a 1. Once I factored out that 3, the x squared number value has a 1 in front of it. Do you guys like the shortcut or no? Okay, well, let's just do it the long way then. Now, please don't lose sight of the fact that 3x is part of our answer, but I'm just going to kind of ignore that 3x and just pretend like the problem started out like this. What are the factors of 4? Factor pairs of 4. 1 and 4 or 2 and 2. Which one could add up to a 5? Has to be this one. So this is going to become x squared plus x plus 4x plus 4. Here's my 1 and 4. I'm going to put a 1 here. The same exact process. The only extra step is here is we had to take a GCF out first. Then we factor what's left like normal. The GCF here is going to be x, and I'm left with x plus 1. The GCF here is going to be a 4, and I'm left with x plus 1. Then I factor out the x plus 1, and what am I left with? Okay, then I'm left with x plus 4. Now my final answer has to include everything. So this is where I got to make sure I don't forget about that 3x I took out. That goes out in front. There's my final answer. Here's my 1, 2, 3 factors. It's 2 problems in one. Exactly. Yes, question. No, once you take the GCF out, that's just part of your answer. Then you ignore it until the very end. Just make sure it's part of your final answer. Then you factor everything that's left just like normal. Now, how could you check yourself? Your answer should multiply back to give you what you started with. Okay, and they get harder to check as the factors get bigger. What I would do on one like this, I would probably do the 2 binomials times each other first and then multiply by 3x, but I'm going to go through how I could check this real quick, just to prove to you this does equal what we started with. I'm going to multiply these 2 back. I would get x squared plus 4x plus 1x plus 4, which is x squared plus 5x plus 4, and now I'm going to remultiply the 3x into that. I would get 3x to the third plus 15x squared plus 12x. Isn't that exactly what I started with? So that is definitely the final and correct answer. This exponent told me I should have 3 factors, and there they are. All right, focus, guys. That was number 1, right? Here goes number 2. Now, sometimes you're not going to have a GCF at all, or sometimes your GCF might just be a number, like on this problem. 2x squared minus 6x minus 20. How many factors should I have when I'm done? 2. How do I know that? Because my exponent of 2. Now let me just tell you, the factors have to be something that's got an x in it to count as one of my official 2 factors. There is a GCF here. What is it? Not a 2x, just a 2. Now on a problem like this, let me tell you guys, technically we don't have to take the 2 out. This is perfectly factorable like it is. However, the only way we're all going to have the same answer, ladies, is if we all take the GCF out first. And I will not give you full credit if you don't take the GCF out first. Even though it's not 100% necessary. We could factor this without it. When the GCF is just a number, it makes your life easier is what it does. Factor a 2 out, and what am I left with? X squared minus 3x minus 10. Then you just do the thing. Yes. Now, does that 2 count as one of my official factors? Not really, because it doesn't have an x in it. Is it still part of my final answer? Absolutely. Now, another reason why I want to take out the GCF is this is so much easier to factor. When the numbers are smaller, the factoring is easier. What are the factors of 10 that are going to add up to a 3 in the middle? 2 and 5. And I don't know if you like the shortcut, but I can really go straight to the answer here. It has to be x minus 5 times x plus 2. I could go through that process, but if the value of a is a 1, then once you identify your 2 factors, you can pretty much write your answer. If you want to go through the long process of GCF and all that good stuff, please feel free. If that makes you feel more secure, it's not 100% necessary on ones like this. Now, only when the value of A ends up being a 1 can you do that. And if you wanted to, you could certainly continue to go through that long process, but please don't forget about your 2. My 2 has to be part of my final answer. I could break this apart into minus 5x plus 2x minus 10. Then I could take out an x and I'm left with x minus 5. I could take out a 2 and I'm left with x minus 5. Then I take out an x minus 5 and I'm left with x plus 2. And don't forget the 2. Now, I just went straight to that step because I knew 1 was my value of A, and I knew it had to be a minus 5 plus 2 combo. Okay, now let's do another one. Yes, question? No? Your hand wasn't in the air? I'm seeing things? Oh, okay, number 3. Let's try this one, please. What about 49a to the third minus 121a? Okay, first of all, it looks weird. It's a binomial, so you should be thinking one of those weird cases. That means it's either a GCF or it's difference of 2 squares, or in a case like this, it's both. Well, it's hard to tell what's missing right now because there's a GCF in there of what? No, I don't think 121 can be divided by 7. The only GCF here is an A. Do you say they both have A's? Let's take that A out of there, and what am I left with? 49 A squared minus 121. Now, hopefully you're recognizing those perfect squares. Once I get the GCF out, what was really missing? The middle or the end? The B, the middle. It's a 0x or a 0a in the middle. But I couldn't really tell that till I got the GCF out. Plus, hopefully you're looking at those numbers going, hey, 49, isn't that a perfect square? Sure is. 121, isn't that a perfect square? Sure is. The B is missing and it's being subtracted. This is that special case of difference of 2 squares. So I bring down my A. And then how do I break this apart? 7a plus 11, 7a minus 11. It's the difference of 2 squares. You just take the square root of each, and one's a plus and one's a minus. Well, you can't factor an a to the third, really. You have to get the g. Your exponent should be even. Okay, so you had to get the a out of there, or you couldn't keep going. Wait, I still want to do some more questions, guys. We got a couple more. All right, number 4. Let's do one where you've got to take the GCF out, and then you have to go through that process. Try this one. 6x squared. Oh, wait. Let's make that 6x to the third minus 3x squared minus 63x. I'm just going to stay quiet while you guys try this one. Probably 2 more after this. All right, guys, I hear chatting. I should just hear your pencils on your paper. Here's where you got to make sure you know about your divisibility rules. I definitely need to take out an x. How can I tell I got to take an x out, for one thing? They all have x's, and when your exponent is odd, then you got to take out some x's. Switch it out with one of those over there if it's dead. In that bucket over there, there's batteries and calculators. Switch it out. But I also need to take out something else besides an x. What else? A 3. Everything up here is divisible by 3. Alright, after you take out that 3x, just pretend like the problem started out as 2x squared minus x minus 21 and factor like normal. Just make sure you don't lose that 3x. It's part of your final answer. So make sure it's included in your final answer. Now this one I cannot do the shortcut on because the value of a is not a 1, it's a 2. What's 2 times negative 21? Negative 42, right? That means my signs are going to be different, and I need a negative 1 in the middle, so I got to add up to a negative 1. I've got 1 and 42, 2 and 21, 3 and 14. It looks like 6 and 7 is the winner. Now, which one has to be negative? The 7. You need them to add up to a positive 1. I'm sorry, you need them to add up to a negative 1. So the 6 had to be positive, the 7 had to be negative. If you've got different signs, I think it's easier to put the negative 1 first when you do this step right here. You don't have to, but some of you have trouble when you have to factor out something negative. This allows my GCF to be positive, but it works either way. The GCF on the first two, I'm going to keep on bringing down that 3x so I don't forget it. The GCF here is just x, right? And you're left with 2x minus 7. The GCF here is 3, and you're also left with 2x minus 7. Then take out the 2x minus 7, and you're left with x plus 3. And then just don't forget about that 3x. So in your final answer, just make sure you have all three factors listed. And there's your final three factors right there. 1, 2, 3 factors with x's in them. Are we good with that? Okay, now, please understand there won't always be a GCF. So you will have some problems that don't have a GCF, and you just start factoring like normal. Okay? But if there is a GCF, you must take it out first. All right, one more, because you're going to have one like this, and this one's really fun, so follow along with me here. Fun for everybody. Oh. Okay, the GCF here. First of all, let's look at a couple of things about this. What's the highest exponent? 5. Guess how many factors we're supposed to have when we're done? 5. Now, when you've got a high exponent like this, chances are you're going to come across some difference of two squares, and that's going to happen here. There is definitely a GCF of x. For sure, I got to take an x out. What else? I can also take out a 3. So I'm going to take out a 3x. Now, one of my x's is now going to be gone. Okay, what am I left with? x4 minus 20x squared plus 64. Okay, now we're used to factoring where you've got x squareds on the front and x's in the middle. Well, we've got x to the 4th on the front and x squareds in the middle. Okay, that just makes it just a little bit different, but it's not that big of a deal. First of all, what's the value of a? A. 1. Right? So 1 times c, 1 times 64 is 64. So let's think of all the factors of 64 that could make a 20. 1 and 64, 2 and 32, 3 won't go in, 4 and 16. Now look at that. Could those make a 20? Now I can pretty much go straight to my shortcut here. Don't do the shortcut? Okay, here's how it would be without the shortcut. Now, I would write this as x to the 4th. This is going to become my middle term, which is not just plain old x. It's negative 20x squared. So how would I write that then? minus 16, not just x. X squared, and not just minus 4x, but minus 4x squared plus 64. Oh, that's fine. That'll work too. Okay, keep on bringing down that 3x. Just don't forget about it. Now, let's talk about this. What's the GCF of the first two? X squared. And what are you left with? X squared minus 16. What's the GCF here? A 4, but I need to take out a negative 4 because this sign right here is a minus sign. If I take out a negative 4, I'm left with x squared minus 16. So now I take out an x squared minus 16, and guess what I'm left with? No, x squared minus 4. Now, there is still a 3x out in front. That's true. Still not done. I have broken it down into 3 factors, but not 5 factors. Here's 1, here's 2, here's 3. And a clue that I'm not done with the parentheses is they still have exponents. They still have x squared. But the nice thing is that each one of those parentheses is a real easy special case called what? The difference of two squares. So I bring down the 3x. Now this can keep on factoring, and a clue that I can keep on factoring is my exponent is a 2. This is difference of two squares, ladies. This becomes x plus 4, x minus 4. Guess what this is? Difference of two squares. It becomes x plus 2, x minus 2. And here's my 1, 2, 3, 4, 5 factors. That's my final answer. Nope. Okay, how did I do the last one? I realized that this exponent that this parenthesis was not done. How could I tell it's not done? I still have an exponent. So I'm not looking at anything else. I'm just looking at x squared minus 16. That's the difference of two squares. So that broke apart into this and this. Then I looked at this, and I'm not looking at anything else. Pretend like all you had in the world was x squared minus 4. That's the difference of two squares. It factors into x plus 2, x minus 2. And then I'm left with 5 factors. Okay, now that would probably be like a bonus. So the other stuff you better know how to do, but I did want you to see one like this. Okay, here is your homework. Page 183, 1 to 40, first column. I'm sorry, 1 to 40. Just in the first column. First step, GCF, if there is one. There won't always be one. Second step, keep factoring if you can. Sometimes you can't keep going because GCF is all you can do. All right, get busy. Get busy. Good luck.